my YouTube channel. So this is our IIT JAM Biotechnology previous year question solution series, right? So in this video, I am gonna discuss 2019 questions, and this is part one of the video. So we will discuss in this video say first 7 questions, right? Okay. So without further delay, let's start with question number 3. So here we have points P, Q, R, and S, and they ask whether these points are like above the parabola and inside the circle. So okay, let's first consider the parabola, right? So we have the parabola as y is equals to 2x square. So this is equation of our parabola, right? So the point here is we say that like a point Pxy, okay, we say that a point xy is the first one like on the parabola. So the point is on the parabola if it satisfies the equation, right? If y is equals to 2x square. And we will say like it is inside the parabola. Like instead of like inside, I wanna use the term like below the curve, right? So the value is said to be below the curve if y is less than 2x square. So the word is below the curve. And the value will be like above the parabola if and only if like y should be greater than 2x square. This is a equivalent condition, right? So first let's check it out, all of these points P, Q, R, and S, whether these points are like above the parabola, on the parabola, or below the parabola. So let's start first with the point P. So P is nothing but 3 by 2 and 1 by 2. So here let me find out the value of 2x square. So it can say like the value of x is 3 by 2. Therefore, 2x square is nothing but 2 times what is the square of 3 by 2? This is 9 by 4, right? So the value is coming out to be 9 by 2. And when I compare 9 by 2 with 1 by 2, I will say 9 by 2 is greater than y by 2, right? So this point is below. Make sense? Because the value of y is coming less than the 2x square. So now let's talk about point Q. So Q is 1 by 2 and 3 by 2. So here the value of x is nothing but half, right? So in this case, the value of 2x square will become twice of 1 upon 2 whole square, right? So this is coming out to be 1 by 2. And this value of 1 by 2 is less than 3 by 2, which is y. So here 2x square is less than y. So this point is above the parabola, right? The third one is let's check out the point R. So the point R is 3 by 2 and 11 by 2. So here like again the value of x is same, that is 3 by 2, right? So therefore the value of 2x square will come 9 by 2, and which is again less than 11 by 2. So we can say that this point is, that is y here, like above the parabola, right? Now the point S. So point S is 11 by 2 and 3 by 2. So here the value of x is 11 by 2, and when we find out the value of 2x square, so this is coming out to be twice of, like what is the square of 11 by 2? That is 121 by 4, right? So the value is coming out to be 121 by 2, which is way larger than 3 by 2. That is y. So in this case 2x square is greater than y, so the point lies basically below. Okay. So in the question they have asked, the point should be above the parabola. So at the first level analysis, the point P is rejected and point S is rejected, but Q and R are the points which are above the parabola. Now we need to check it out whether the points are inside the circle or yes or no. So again, Like for inside the circle, we have the circle given as x square plus y square is equals to 4, right? So we say that point is on the circle if it satisfies the given equation, right? So x square plus y square is equals to 4 is true. We say that point is inside the circle if the value of x square plus y square is gonna be less than 4, and point is said to be outside the circle. So this will be like outside the circle if the value of x square plus y square is coming out to be greater than 4, right? So let's check it out the point q and r. So for point q we have the value of x square plus y square is, so here x is half, right? So 1 by 2 whole square plus 3 by 2 whole square. So this become nothing but 1 by 4 plus 9 by 4. So, right. So this is 10 by 4, and 10 by 4 is less than 4, right? So that means this point is inside the circle. Okay, now let's check the point R. So here for R, like the value of x square plus y square will become 3 by 2 whole square plus 11 by 2 whole square. So this will become like 9 by 4 plus 121 by 4, and this is coming out to be 130 by 4, and which is nothing but somewhere like 65 by 2, way greater than 4. So this point is like outside the circle, right? So Q is the answer here, like this is the point which is above the parabola and inside the circle, right? So Q is the correct answer. Okay, let's move to the next question. So here we have a set, say U, which contains the value as 1, 2, 3, 4, 5, and it say that a subset S is chosen uniformly at random from the non-empty subsets of U, right? So first of all, total number of subsets of U is total number of subsets, right? So the formula is like 2 power the cardinality of U. So here the cardinality of U is 5. There are like 5 terms here. So the number of subsets is 2 power 5, which is coming out to be 32. But remember, 5, like the empty set, is always considered to be a subset of U here, right? So if we say total number of non-empty, right? So total number of non-empty subsets. So this coming out to be 2 power 5 minus 1, that is 32 minus 1, and then 31, right? So 31 is basically the total number of non-empty subsets. Now, the point here is we have to choose a subset S uh, such that S does not contain two consecutive elements, right? So for example, we have the elements like 1, 2, 3, 4, and 5. So the point here is if it contain 1, so it cannot contain 2, it cannot contain it cannot contain 2, it can contain 3, it can contain 4, as well as it can contain 5, right? So the only possibility is it is not allowed to have two consecutive elements. Okay, so now the question is like how many such subsets are possible, right? So how can we create such subsets? Like the idea is if we have one, right, I cannot have two, but I can, if I can have three as well, I cannot have four, I can have five as well, right? So any subset which contain 1, 3, and 5, right, so will satisfy the given property, right? Similarly, if we have a subset that contain 2 and that contain 4, so such subsets are satisfy the given property, right? Like all subsets which do not have any two consecutive elements, right? Similarly, we can have like 2 and 5, right? So we can make subsets out of 2 and 5 such that these subsets will not contain any consecutive elements, right? Similarly, we can have like 1 and then uh 4, right? Because 1 3 5 is already we discussed, so every subset that contain 1 3 or 5 will be there, but 1 4 is one which is also like a possibility, right? So anything else? 1 3 3 5 we already discussed, 2 4 we already discussed, so 2 5 was the possibility, 1 4 was the possibility, right? And 2 4, yeah, that's already done. So 2 4 and 2 5 are the possibility, right? So how many subsets we can generate from here? So it's basically like 2 power 3 minus 1. Why minus 1? Because I want to make sure no empty subset is selected, right? So when we say 2 4, so here we can have like 2 power 2 minus 1. So I can say like 3 such subsets are possible. So it's like a singleton 2, singleton 4, and a combined 2 4. Now, here, when we say 2, 5, I will not include the singleton 2. I will not include the singleton 5 because singleton 2 is already calculated here and singleton 5 is already calculated here, right? Only one subset that will contain both 2 and 5, right? Similarly, when we say 1, 4, again, we will not include empty one. We will not include singleton 1 because already here. We will not include singleton 4 because already here. So it's again a one subset, that is 1 4, right? So total number of such subsets will become, I need to just add up all of these numbers, and this is coming out to be like 7 plus 3 plus 1 plus 1, that are 12 subsets, right? So the probability is nothing but the number of favorable outcomes divided by total number of outcomes, right? So let me write down here. So it is like favorable outcomes divided by total number of outcomes. So this is 12 by 31. So I can say that like option D is correct here, right? Okay guys, let's move to the next one. Question number 11, right? Okay. So here they have given us like two value A and B, right? But before going to the value of A and B, one simple point here, like we know that if the value of limit n approaches to infinity and x power n, right? So if like so this will go to infinity if the modulus value of x is greater than 1, right? So if x is greater than 1 and when we do the power infinity, the answer is always gonna be infinity. And it will be like static at 1 if let's only talk about for the positive number. So if x is equals to 1, right? And this will be 0 if the value of x will lie between 0 and 1, right? So in this case, like if I say 1 by 2, so for 1 by 2 power infinity will gonna be 0, so the value will keep decreasing as we keep increasing the value of n, right? And eventually approaches to 0. So here just assume that I am talking only the case when x is greater than 0, right? And belongs to real number. So we will gonna use this one particular fact to solve out this question. So here you can see that the value of a is nothing but root 5 plus 1 by 2. And my point here is root 5 is something greater than 2 and we are doing like plus 1. So it is so the numerator is greater than 2 and when we divide by 2, so the value will gonna be greater than 1, right? That simply means the value of limit n approaches to infinity, a power n is nothing but infinity, right? So here the value of b is root 5 minus 1 by 2. Now, see, root 5 is something greater than 2. So when I subtract minus 1 from here, the value will become less than 2, right? Why I'm saying this? Because root 5 is definitely less than root 9, that is 3, right? So if value of root 5 is somewhere between 2 and 3, so value of root 5 minus 1 will be somewhere between 1 and 2. And when we divide this whole value by 2, so I can say that the value of b will gonna be less than 1. And therefore this implies the value of limit n approaches to infinity b power n is gonna be 0, right? Okay, so now we will use these two conditions to solve this question. We need to find out like limit n approaches to infinity, a power n plus b power n, and this divided by like a power n minus b power n. So this will become nothing but like limit n approaches to infinity. I'm just taking a power n outside, so this will become nothing but 1 plus b upon a power n, and the whole value similarly 1 minus b upon a power n, right? This makes sense? Okay. Now, okay, look, what about b upon a? If we see like what about b upon a? So b upon a is nothing but like root 5 minus 1 upon root 5 plus 1, right? So obviously this is gonna be less than 1 and positive, right? So therefore this limit b upon a power n will become 0, right? So I have 1 plus 0 divided by 1 minus 0 here. So this is coming out to be 1 divided by 1, that is 1 only. So I can say that option A is correct. Okay, let's move to the next one. So in how many way can we write the element 1, 2, 3, 4 in a sequence x1, x2, x3, x4 such that xi is not equals to I? Right? So the point here is like suppose we have 4 seeds number with 1, 2, 3 and 4, right? So it's saying that at the seat 1, only x2, x3 and x4 are allowed. X1 is not allowed. Similarly, at seat 2, x1, x3 and x4 can sit up. Similarly, at seat 3, x1, x2 and x4 can sit up. And similarly, at seat 4, only x1 and x2 and x3 are allowed, right? So this is simple questions of D arrangement. I'm not sure whether you are familiar with the term D arrangement or not, but this is questions of D arrangement, right? And we have the formula of finding the total number of such way, and the form and here the formula say basically the n factorial divided by 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial, and continuing this way we will have like minus 1 power n into 1 upon n factorial as the last value, right? So here the value of n is nothing but 4. So let's apply the formula. So we have 4 factorial here multiply with 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial, and then last we have like 1 upon 4 factorial, right? So this will become like 24 into 1 minus 1 plus half minus 1 by 6 plus 1 by 24. So when we multiply with 24, this is coming out to be 12 minus 4 plus 1, right? So it is 8 plus 1, that is 9. So here 9 is the correct answer. So option A is correct here, right? Okay guys, let's move to the next one. Question number 13 belongs to the trigonometry, right? So in this question, like they simply ask what is the simplification form of this value, right? So I have to simplify sine A divided by like 1 plus cos A, and then we have like 1 plus cos A upon sine A, right? So let's simply take like LCM of denominator. So this is coming out to be sine A into 1 plus cos A, and this value will become like sine square A plus 1 plus cos A whole square, right? So let's simplify this. So we have like sine square a plus 1 plus cos square a plus 2 cos a, and the whole thing divided by sine a and multiply with 1 plus cos a, right? So the value of sine square a plus cos square a is nothing but 1. So we have like 2 plus twice of cos a here and divided by sine a times 1 plus cos a. So I can write it down like twice of 1 plus cos a divided by sine a into 1 plus cos a, right? And we can cancel out 1 plus cos a to 1 plus cos a. We have 2 upon sine a, which is nothing but twice of cosec, right? So option B is correct. Okay, let's move to the next one. That is question number 32. So here we have a set U. U is like all natural numbers between like from 1 to 15, right? And P is a subset of U consists of all prime numbers. So we can like directly find out what is the value of P. So it will contain all the prime numbers less than 15. So 2 is the first prime number here, 3 is the second, 5th, 7, then we have 11, and then we have 13. So this is coming out to be my P, right? And Q is consist of all even numbers. So again, it is a subset of U, so it will contain less than or equals to 15. So 2, 4, 6, 8, 10, 12, and 14 are the possible values, right? Now R is something which say all numbers again like it is a subset of U but consists of all multiples of 3. So multiples of 3 are like 3, 6, 9, 12, 15, right? That's all. So given the value of P is nothing but P minus Q, right? Okay, if you know the subtraction, that simply means all those elements which belongs to P and the condition is should not belongs to Q, right? Must be in P but not belongs to Q. So let me find it out such elements. So here 2 belongs to P and 2 is also in Q, so 2 is rejected, right? So 3 is one number. So that simply means I can only have odd prime numbers, right? So 3 is part of this, 5 is part of this, 7, 11, and 13 because Q contain even numbers, right? Okay, so this is my T. So first point here, I can directly say that number of elements in T is nothing but 5, right? So option B and option D is automatically rejected. Now I only need to like concentrate on option A and C, where number of elements in T is 5, and now I need to check how many elements we have in T union R as well as in T intersection R, right? So T union R, T is like 3, 5, 7, 11, 13, and R is nothing but multiples of 3. So 3 is already there, but all other values like 6, 9, 12, and 15 will come here, right? And so this implies the number of elements in T union R is nothing but 3699, right? Similarly, T intersection R will only talk about the common values. So in T and R, I can only find 3 as the common values. So this implies the number of elements in T intersection R is nothing but 1, right? This is correct. T union R is 9 and number of elements in T is 5. So both option A and C is correct here, right? Okay. So let's move to the next one. Question number 33, which is the last question for this video, right? So fx is given as x minus 1. Okay, so let me write here fx is given as the product of x minus 1, x minus 2, x minus 3, and x minus 4, right? So the point 1, 2, 3, and 4 are the zeros of the function fx, right? So I can say that if the value is less than 1, so the sign is always gonna be positive. So fx is gonna be positive here. Between 1 and 2, it should be negative. Between 2 and 3, it is again positive. Between 3 and 4, it's gonna be negative. And after 4, it's still gonna be a positive, right? Okay. So now they give us the value f at 3 by 2, right? Alpha is f at 3 by 2. So 3 by 2 is something between 1 and 2, right? So this definitely gonna be less than 0 and alpha have the negative sign. Now the beta is something f at 5 by 2 and 5 by 2 is something which will lie between 2 and 3, right? And here sign is positive, so I will say beta should be greater than 0 here. Now the gamma is the value of f at 7 by 2 and 7 by 2 is something which will lie between 3 and 4 right here. So I can say that the gamma should be negative or sign of gamma is negative here, right? So let's check out the option. So first option say alpha and beta have the same sign. Wrong, because alpha and beta have the opposite sign, right? So option A is not correct. Option B say alpha and gamma have the same sign, and that is correct. Both have the negative sign. Option C say beta and gamma have the same sign, which is again wrong because beta is positive and gamma is negative, right? Then it say alpha beta and beta gamma have the same sign. So first of all, let's see alpha beta, right? So alpha is negative, beta is positive, and the product of negative into positive is gonna be negative. Similarly, for beta gamma, beta is positive, gamma is negative, so the product of beta and gamma will gonna be negative. And anyway, I can say that both alpha beta and beta gamma have the same sign. So option D is also correct, right? I hope these solutions are clear to all of you. So that's all for this video.